40 light-years away, a fascinating system of 7 Earth-sized planets orbits a dim red dwarf star, TRAPPIST-1. But could these worlds hold onto moons? The TRAPPIST-1 system has captivated astronomers since its discovery in 2017 due to its incredibly compact and unique structure. 7 Earth-sized planets are tightly packed around a cool, red dwarf star, making it one of the most compact planetary systems known. Crucially, 3 of these planets orbit within the habitable zone, raising the exciting possibility of liquid water. However, a major question remains. Can a system so compact and dynamically active sustain stable moons around its planets? Researchers address this by running thousands of computer simulations, starting with each planet in isolation to establish a baseline for moon stability. They placed 100 virtual moons in circular orbits around each world, spacing them from the Roche limit outward, where tidal forces tear them apart. The isolated tests confirmed theoretical predictions. Moons could remain stable in a zone extending to roughly half the Hill radius. But the TRAPPIST-1 system is highly interconnected, so the simulations had to account for all 7 planets. The planets exist in a resonant chain, like a gravitational clockwork mechanism, constantly tugging on one another. When neighboring planets were included, their combined gravitational interference significantly squeezed the stable zone for potential moons. This resonant squeeze was particularly noticeable for the innermost planet, TRAPPIST-1b, and the habitable zone planet, TRAPPIST-1e. The contraction wasn't dramatic from individual planets, but the combined gravitational influence of the full system produced the strongest effect. The outer stability boundary contracted to about 40% to 45% of the Hill radius for each world, yet still leaving room for moons. While small, stable orbits are possible, tidal forces impose a strict size constraint on any potential moons. Larger moons would be subject to tidal forces that would cause them to gradually spiral inward and crash into their host planets over cosmic timescales. Only moons smaller than about 1/10 millionth of Earth's mass could survive these forces throughout the system's lifetime. They must stay small and close to home. The research concludes that TRAPPIST-1's compact, resonant architecture does not prevent the existence of moons, establishing a crucial possibility in this fascinating planetary system.